how to identify whether it is a series or a parallel circuit. So let me draw one simple circuit over here. This is the battery, which we will denote as E. This is the first resistor. This is the third resistor. We'll draw the second resistor over here, and then over here we'll draw one more resistor, right? And then we connect them. Now if I ask you, how are these two connected? You may say series because they're right next to each other. You may also say series to this one because they're also connected together. You may say R2 and R4, they are in parallel. What if I tell you all of these things are wrong? So to understand that, and don't worry, by the end of this video, hopefully you'll understand how to identify them. So the first thing you need to understand is the circuit types, right? So circuit types, there are 4 circuit types. The first one is series. Second one is parallel. Third one is series parallel, and the fourth one is complex. Now we don't need to worry about complex in this video because that is a bit advanced. We'll only focus on series and parallel for this video. And to understand series and parallel, there are 3 terms that we need to understand properly. The first one is called element. Now what is an element? Element can be 2 things. It's either the source, which is the power source or the battery, or element could also be a resistor. So either of these 2 things are called an element. Next thing that you need to understand is a branch. Now what is a branch? A branch is a single element such as voltage source or resistor. You may think element and branch are the same thing, almost. For now, that is almost the basic knowledge that you need. Last thing is node. What is node? Node is the point of connection between 2 or more branches. And to understand series and parallel, node and branch are the 2 things that you need to understand completely. Now, I'll draw a circuit so you understand the concept of node and branch better. So we start with the battery, of course, and then we draw one resistance over here, one over here, add them, and then we go a bit over here, add them, and over here let's say we have an ampere meter. You do not need to worry about this thing for now, okay? But we'll just keep it there. Now, if you really think about it, the circuit started from here, right? This is where it started from. So basically this is the battery, right? This is the battery. And then the battery is connected to this first one. Let me actually name it as R1, R2, R3. So the battery is connected to R1 with this one single wire that I just draw in blue. And then if you can tell, from R1 to R2, this is actually one single wire, and this is actually the extension of the same wire that came from R1 till here where we see a breaking point. This is the breaking point. This is the breaking point, because over here, you can ask me, hey, in this path, it went from here to here, and then it went from here to here. So these are two different paths. So how can it be the same branch? The same branch or the same node? Well, if you think about it, is there anything present over here? No. We will only call it a single branch or a single node when there is nothing inside. So this line, it keeps going and then it goes this way. Here is one break. Then this line, it also keeps going over here and there is another break, and it also keeps coming here until it says this break. So if we actually start naming them, if we start naming it, let's say this is node A, this part, and then this part is node B, this part is also node B, this part is also node B. And right after the break, this till here, this till here, and this till here, these are connected with the same wire. Why? Because over here there is no break, there is no other element, there is no other branch present. So we can call this entire thing, this is C, this is node C, this is node C, this is node C. Now don't be scared. It still might seem a bit intimidating at first, but once we practice through a few today, I hope that you'll understand what exactly I mean. Now, let's come to the topic of series and parallel. So when is a series or a circuit called in series connection? You might tell me, what the heck did you just write? What do you mean by exclusive over here? And what is happening over here? So just be patient. You'll understand this at the end. But just keep this in mind for now. You don't have to understand this. We'll explain it at the end. So this circuit that I just drew over here, if you see over here, what if I'm asked to redraw this, right? I'm asked to redraw this circuit. So at first, we'll draw the battery over here. And then this is the A node. Now, there is one break over here, which is the R1. Let me just erase this, which is the R1. And immediately after R1, what do we see? We see B. Now from B, you can see that there are three paths. So this is B, right? As you can tell, left of R1 is A and right of R1 is B. And that is exactly what we wrote over here. And then from B, as you can see, B has three paths. So we do the same. We create one path here, one path here, one path there. And from there, we draw R2, we draw R3, and then we draw this. And then all of these, they combine to C. And so we draw this, sorry, my bad. We draw this, we draw this, and then we bring this, and all of this is C. And mind you, these two are the same circuit. Now, what do the connections mean? How are they actually connected with each other? Well, I told you the definition for series. Over here, we actually don't have anything in series, but we do have resistors which are connected in parallel, and they are R2 and R3. So how does that happen? Well, the definition for parallel circuit is that two elements must be connected with the same two nodes, and the voltage must be equal across the circuit. Now, let me just explain what happened here. If you noticed, R2 and R3, they only have two nodes. And what are they? B and C. They are connected to the two same nodes. They do not have any other node. So we can say that R2 and R3, these two are in parallel. But R1 and R2 or R1 and R3, they are not connected in series. Why? Remember, when we wrote this definition of series, we said two or more elements share one exclusive node. So what does exclusive mean? Well, over here, if you see, if these two did not exist, let's say this did not exist, we could have easily said that R1 and R2, they are in series. Why? Because they do share one node, and this B node is only exclusive to R2. There is no other connection in B like R3. In this circuit, R1 and R2 are sharing B, which is their exclusive node. It is not connected to anyone else, which is why in this circuit, R1 and R2 are in series. But if when we have this circuit, B is shared by R2 as well as R3. So that cannot happen, which is why R1 and R2, we cannot call that they are in series. However, R2 and R3 are in parallel. Well, if you still did not understand, we're going to do a few more examples till you understand it absolutely completely. So let me draw another circuit over here, which is something like this. At first, we draw the battery, and then in the middle goes another line, goes another line. Over here, we finally have our R1, and then over here, we have our R2, and then over here, we have this extension, and then over here, we have our over here, we have our R3, and then just a bit below, we have our R4, and then all of them are connected right over here. This is E. So try for yourself and see if you can identify everything, which are the nodes and which are the branches. I'll give you can just pause the video right now and try for yourself. Okay, if you could do it, congratulations. And if you couldn't, no worries. I didn't get it my first time either. So we're going to do that again. So, well, we see E1, it starts from here, it's going, oops, a break. It's also going over here, oops, a break. It is also going from here, oops, a break. What does that mean? That means this over here, 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 and this over here. All of these are the same node. Why? Because there is no break, there is no branch, there is no element. So all of these are the same. And then over here, there's another wire, and oops, there's a break. What does this mean? This means that there is a B node over here. And then from here, we keep going, no break, we keep going. You could also say it comes from here, it comes from here, it comes from here, it comes from here. It's going. Oops, a break. What does that mean? That means that this is C, 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 and this is C. I hope now you're understanding what it truly means to have nodes and branches. And for now, I'm going to ask you again to try to redraw this circuit on your own, because now I've shown you all of the nodes. So pause the video and try for yourself. Well, at first we draw E, which is over here, and then of course this is A. And then what do we see? From A we have R1 and R2 as well as R3. So what do we need to do? We need to actually do 3 over here, R1, and then R2, and then R3. So we draw R1, we draw R2, and then we draw sorry, let me move it a bit to the left. Okay, moved it a bit to the left, and then we draw R3 over here. Now if you can see, from R3 we have R4 in series, because as you can see, they share only B, right? B is only exclusive to R3 and R4. B is not shared by R2 over here. That does not happen. So we can say that R3 and R4 are in series. And if you notice, for R1 and R2, they actually share A and C, right? They share only two nodes, which is common to them. So we can say that R1 and R2, they are actually in parallel. So we can actually join these two, which means that, okay, they are in parallel. And then R3 is in series with R4, and then all of these actually join together, and this, you could say, is the redrawing of this, where this is A, and then over here we have B, and then this junction point is C. I could also draw it something like this. If I just make the wires bigger, it's also the same thing, right? Now let's draw another circuit. So over here we have the battery, then we have the R1, then we have the R2, and then over here we have the R3, and then over here we have the R4, and they're connected like this, and then over here we have the connection. So pause the video and try for yourself. Now you can see, okay, so this is one part, so I can say this is A, because there's a break, and then we go from here to here, okay, one break, and then from here to here, okay, another break, here to here, another break. Okay, so I can say that all of these are B. This, these are B, and then here to 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 here. I can say that all of these are the same nodes, because there is nothing in between them. There is nothing that breaks. We can say that all of these are the same wire, technically, the extension of the same wire. So once you've identified them, how do we redraw them? Pause it and try for yourself. So it's basically the same thing. At first you draw the E, and then when we have the A, we can say that this is R1, and then from B, this is A, and if this is B, from B we have R2, from B we have R3, and from B we have R4. All of them are originated from B, and then they connect together to C point. This is how you can do it. And now I hope that the concept of series and parallel and how to identify them is a bit clearer for you. So this will be the last practice for today. Let me know if you need more videos after this, but hopefully you have understood it. And then over here one line goes, and then it breaks to 3 lines. This is R1, this is R2, this is R3, and then they extend like so. And then over here we have R4, over here we have R5, and then over here we have R6, and then this is the extension. So go ahead and identify all of the points. So you can say that this goes here, okay, goes here, oops, one break, oops, one break, goes here, oops, another break, goes here, oops, one break, oops, one break. So we can say this is A, 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 this is also A, this is also A. And then from here. Okay, this wire goes, oops, a break, but I can also bring it from here. Oops, another break. So over here, this is B, this is B, this is B, this is B. And then this wire extends, comes here. We can also go here, break, or we can also go here, we can also go here. So I can say that this is C, this is C, this is C, this is C. These are all basically the same nodes. So now go ahead and try to redraw it. Once you figured out everything, if you can say, if this is E, how many of these origin from A? 1, 2, 3, 4, 5. So let me draw 5 branches from 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 5 of these that we have that originate all from A. So this is R1, this is R2, R3, R4, and then R5. And then we can see that R4 and R5 have in common B, and then B has a break and it goes to R6, which is C, and then C is connected to R1, R2, and R3. So R1, R2, and R3, they're connected with R6 over here. And there you go. This is how you can redraw it. So by now, hopefully you understood what are nodes, what are branches, and how do you redraw a series and parallel circuits. And this is all for today. Thank you.